All right, so here we are looking at some ideas for geometry. It says find the area of the regular polygon. Regular is kind of a big word there. So let's just get down to the basics here. What does it mean to be regular? Well, regular means that all sides and all angles as well, all sides and all angles are congruent all the way around. That means that this 8 and this 8 and this 8 and this 8 and this 8, they're all the same all the way around. Similarly, I could kind of extend some lines here. Let's kind of show some other lines in here, like this line and this line and this line and this line and this line. Those are like a radius going all the way around a circle. What they gave us was this length here, and they said it was 5.5. So if I were to kind of erase this little piece and you could see what that was, that said 5.5. And that is talking about this length right there. So 5.5 and that length there. So what are we looking for? It says the area of the regular polygon. Well, here's what I see. I see a bunch of triangles that are all the same. I got this one, this one, this one, this one, all the way around. How many of them are there? There are 5 triangles. And then the challenge here is, well, they gave me a base and a height. So they gave me both a base and a height. And that's pretty awesome, because if I could find the area of one triangle, like let's say the area of this triangle, that would just area equals 1/2 times base times height. And the base and height are 8 and 5.5. Well, half of 8 is 4. And then 4 times 5.5 would be 22. So that's the area of one triangle. But how many are 5 triangles? So that's going to be 5 times the area of one triangle, which is 5 times 22. There you go. Awesome piece of cake. Wait, so what is that? That's 110. There we go. Sweet. So now what? What could we do with these other ones? Well, this other one's, a little different here, but not a big deal. And you're like, whoa, how do I do that one? Well, let's see what we have going on. It's actually very similar, because I see that this is 14. Well, so is this 14, and so is that 14 over there. So we got 14 and 14 all the way around. And then if I were to kind of split this up into triangles, I could make 3 triangles out of this one triangle. Kind of silly to keep making triangles out of triangles. But if I just wanted this area here, just for that one, that's again 1/2 base times height. So we got 1/2 base times height. And what is the base and height? Well, that's going to be 14 and 4. Half 14 and 4. Piece of cake. Right? Yeah, it looks like it. 7 times 4, because half of 14 is 7. 7 times 4 is 28. And we got 3 of those, so the area of 3 triangles is 3 times 28. Well, 3 times 30 would be 90, so subtract 6, and we got 84. Awesome. Now let's look at 33, a little bit higher up. We're going to split this video kind of into 2 parts, but a little bit higher up on the difficulty here, because notice they sure gave us something. They gave us this 12, but they didn't give us anything else. Because the question is, if I only knew the length of this side, if I only knew that, then I could figure this out. Well, let's see what I would come up with. So I have this height, and I got this base, and let's see if we split it up into triangles. Could we do anything with that? We sure can, because right now what I'm seeing is, let's go to make this in a different color too. How about red? So if I were to kind of trace over this line and then this line and this line, I'd have, a right triangle here. And we know a little bit about right triangles, especially with like SOHCAHTOA. So what do we know? Well, we know that this triangle has 360 degrees in the middle. But that 360 degrees is split into 1, 2, 3 separate triangles. So we're going to split that in 3. Now it would tell me that this is 120, and this is 120, and this is 120. But I only took half of that. So right here, this is half of that central angle, which was 120. And that's 60 degrees. Okay, so what can I do with that? Well, I know that this is 12. And if that's 60 degrees and I'm trying to find this side, well, that's just a SOHCAHTOA calculation. So let's see. SOHCAHTOA. And for me to calculate this, I see that I have, here's my angle. So this side is the adjacent, and this side is the opposite. And that means that I'd be using tangent. So there's tangent. The angle is 60 degrees. And the opposite over adjacent, because TOA means opposite over adjacent, is going to be question mark over 12. Now from here, I just multiply both sides by 12. Let's see what we get. And so 12 times tangent 60. I'm going to go to my Google calculator. So 12 times tangent of 60 degrees. And this is clicked in radians. I want degrees there. And I'll close that off, and equals 20.74, 20.784, I should say. So let's take it back to where we were, 20.784. So the question mark equals 20.784. But here's the catch. That was only this piece there. That's 20.784. So I got to double that. I got to multiply that by 2. So I'm going to take that and times 2. That gives me about 41.5 or 41.6. So we know that this is the whole thing. So half of the base equals 20.784. So the whole base is really, what was that, 41.5, I think we came up with. About 41.5, 41.6. Okay, so now what do? We got one triangle. One triangle would be area equals half base times height, so half the base, which is 41.5, times the height, which was 12, and that would give us 6 times 41.5, it looks like. So let's multiply that by 6 times 6. Whoops, don't want that. Equals 249. So now we're at 249. So that's 249 approximately. And there's 3 of those. So then we got to multiply that by 3. So then we're going to say 249 times 3. I know I'm taking up all the space from this other one too. But let's see what we end up with, and we'll wrap it up there. So we're going to take that and times 3. And it's 748.2. That wasn't too bad. So the area equals 748.2. 748.2. That was a lot of work. Okay, so I'm going to show some more of these as well in the following examples, but I'm going to wrap up this video right here.